Welcome to Freshwater Habitats. The learning outcomes for this presentation are to introduce you to some key characteristics of streams and rivers, lakes and wetlands. And as you can see from the photograph, these freshwater habitats typically occur in close proximity to each other and to other habitats like our woodlands and grasslands within the Irish landscape. Let's first start by looking at streams and rivers. So what are the characteristics of streams and rivers? They have unidirectional flow with variable velocity. They are linear in form with changing gradients, and we see this as we go from the top of our catchment all the way out to our estuaries. Erosion and deposition is a constant battle. In the top of our catchment, we expect there to be quite a lot of erosion. In the middle sections of our catchment, we expect there to be a balance between erosion and deposition. And then as we come out to our lowlands and into our estuaries, we expect there to be more deposition of sediment. They are complex systems. We have changing substrate, they vary in size, we have different types of vegetation throughout our channels, and we also then have different types of water chemistry. And there's lots of high stream variability because of these different complex variable channel types. So in reality, no two systems are the same. And this is because they have different geology, soil types, geomorphology within the catchment and riparian vegetation. But they also then all have different land use types alongside. River networks are classified, and in Ireland we have a particular type of classification called a Strattler classification method that's used to determine what is a stream and what is a river ultimately. And in this diagram, this Strattler classification method is illustrated, and it basically helps when analysing longitudinal changes in streams within a catchment. So if you're operating within your catchment and you're trying to decide what type of system you have, whether it's a stream or a river, this method can really help. Typically here what we see on the diagram is that all of the systems that are classified as one are referred to as first order streams. These tend to be single, unbranched headwater channels and are really found at the top of our mountains or at the very, very beginning of where our system is originating. Then as we move down the catchment, we expect to get various numbers. So as the image shows, the next order is 2. These are second order streams, and these are only developed when you've got 2 first order streams meeting each other. So as the image shows, 2 firsts then make a second. And this is kind of then how the classification method occurs. You get a third order stream when 2 second orders meet, and all the way down until you get to as high as orders 10, 11, 12. So when we're looking at this from our Irish perspective, headwater streams here are referred to as orders 1 to 3. And again, you might hear a lot of people talking about first order streams, second order streams, or even headwater streams. And this is essentially what they are referring to. Middle order streams are orders between 4 and 6, and then really rivers are only orders higher than 6. And this really means that the majority of our systems in Ireland, 87.7%, are actually classified as headwater streams. So most of you are operating within headwater streams and middle order streams, despite them maybe potentially being called a river. So how are headwater streams characterised, and what are the things you need to look out for? Headwater streams tend to be orders 1 to 3. They tend to be upland streams and that are narrow in width. So you should be able to jump across them, or if they're a little bit wider, wade through them easily. Many may be shaded by trees, and for many upland systems they're actually predominantly shaded by conifers, but this may be different in the catchments that you're working with. Channel slope is steep, and because of this we have rapid turbulent flows. This then results in high or variable discharge, which is very dependent on rainfall. Here, your water levels can rise and fall very, very quickly over a space of 2 to 3 hours, depending on the amount of rainfall coming into the system. Substrate particles are large, so they tend to be quite large pieces of rock like cobbles, boulders, and exposed bedrock in some cases. Channel erosion is active and frequent, and this again reflects levels of rainfall coming into the system. They are a major source then of water and sediment to your middle order streams and your lowland rivers. They are cold and have high oxygen or oxygen saturated waters. They have low conductivity. In most cases, you would expect it to be around 100 or less. And they're naturally acidic in pH. So again, having a pH of around 6.5 wouldn't be unusual. So when we move to middle order streams, we typically tend to be lower down in our catchment. But what are the characteristics to look out for? Here we're expecting streams to have an order of 4 to 6. This means that they are getting much, much bigger in terms of their width and also in terms of their depth. So they tend to be wider and deeper. Stream gradient has reduced, and because of this, the water flow has also decreased, but it is moving at quite a good pace. Volume to discharge then is greatly increased because you've got a wider, deeper, essentially river channel, which can carry more volume. Substrate particles tend to be fine, so here we're looking at things like gravel, sand and silt. Water and sediment are transported with ease, and this often makes the water a darker colour, and then particularly during high rainfall events, a very kind of chocolatey brown colour. These sections of the river carry the sediment, so this is where the sediment is typically on the move from upland systems. Deposition, though, is balanced out with the ability to carry this sediment. So we have areas then where we can get gravel banks or sand banks. But there can also be lateral cutting and erosion, particularly where there may be limited riparian vegetation to protect the riverbank, particularly during high flow rainfall conditions. Finally then, we're in the lower reaches of our catchment and we're interested in what the characteristics of lowland rivers are. So here things to look out for are orders greater than 6, large wide river systems that have low gradients, and because of these features then they tend to be deep, slow flowing systems. They do have stable, predictable discharge and tend not to be as impacted by high intense rainfall events compared to our headwaters and middle order streams. This is the section of the river that has the maximum volume to discharge ratio, and this is because the water then is going out into the estuary. Substrate particle size tends to be very fine, here really looking at silt and clay. And deposits fine silt sediment loads then to estuaries. So here really we're looking at everything happening within our catchment and in the 3 sections of our streams and rivers is going out into the marine environment. So I hope this section has given you a little bit of insight into how we classify streams and rivers in an Irish context.
So the next freshwater habitat we're going to look at is lakes. So characteristics of lakes. So these are areas of open or standing fresh water that lack a strong unidirectional flow of water. So they differ from a wide stretch of river because the water circulates within a basin as opposed to moving in a strong unidirectional flow. So the water is usually localized within one basin, but they can occur across several basins which are connected to each other by straits. So lakes have distinct flows into, through, and out of their basin, and they're usually surrounded by dry terrestrial land. They're usually naturally occurring, but they can be modified, so for example damming to create a reservoir, or they can also be entirely artificial, so for example ornamental lakes or flooded quarries or gravel pits. Natural lowland lakes and islands were mostly formed during the last glacial period due to erosion, and they often have a ribbon shape or a morphology. So they're long, thin, and deep, like the lake image on the slide. So lakes are usually permanent water bodies, but they can be temporary. So for example, in the case of tailocks, which are mostly found in limestone karst areas of Ireland, these fill and empty with changes in the level of the water table, usually being very low or empty during summer and autumn, and then full in winter. So the role of lakes within the catchment. So the water quality of lakes is intrinsically linked to the catchment land use. So lakes are linked to the wider catchment through the stream and river network in a series of inflows and outflows. Because lakes have a slower flow, the water circulates within the basin. Lakes have a higher water residence time, so the water stays within the basin for a longer duration compared to rivers or streams. And this means that pollutants and nutrients can accumulate within lakes. So lakes are a good indicator of what's occurring in the wider catchment. And lakes are characterized according to the concentration of nutrients that they contain, and this is called the trophic status, ranging from eutrophic, which have the highest number of nutrients. We then have mesotrophic, moderate amount of nutrients, and oligotrophic, which is a low amount of nutrients. So nutrients occur naturally, but their concentrations can be modified by catchment land uses, such as point and diffuse sources of pollution. The amount of nutrients within a lake is important because it determines the primary productivity of the system, so the amount of plant growth, which therefore has a knock-on effect for the entire lake food chain and the lake ecosystem as a whole. So if we look at the lake habitat, there's two main areas. So we have a shallow area around the perimeter of the lake, which is called the littoral zone. This is an important habitat for our plants or our macrophytes. So we can have emerged plants, floating plants, or fully submerged plants. We have macroinvertebrates, either free living within this area or in the sediments. And we also have fish, which will move between the littoral zone and the limnetic zone. Then we have our limnetic zone or our open water zone. This is an important habitat for our phytoplankton, which are small plant-like microscopic organisms. We have our zooplankton, which are our small animal-like organisms, and then we have our fish. So slightly different food chains between our littoral zone and our limnetic open water zone. The next habitat we're going to look at is wetlands. So characteristics of wetlands. So it's an area that is saturated with water, either permanently or seasonally. The water table or the groundwater is at or near the surface. Wetlands are an important feature of the catchment landscape because they're a transition zone between our terrestrial land and our deep aquatic habitats like our lakes. There are different types of wetlands, and they're classified according to the soil and plant types. The most important one we'll be looking at in this course is bogs or peatlands, but we also have fens, marshes, and swamps. So wetlands are really important features of the catchment. They slow the flow of water through the catchment, which has a number of benefits. So it allows for pollutants and sediments to settle out of the water before they reach a lake or a stream network. It means they can filter out and consume excess nutrients in the catchment before they enter watercourses. And in general, the higher proportion of wetlands you have in the catchment, the better the water quality. Wetlands also act as a sponge, so they retain a large amount of water and they can prevent flood risk downstream. They're also really important habitats for specialist plant and animal species.
Thank you for listening. If you have any questions about the content of the Freshwater Habitats presentation, or even freshwater habitats in your own area, please get in contact or log in to the Q&A session on Friday morning at 10 a.m.